In the summer of 2024, we were contacted to see if we could help with a steam-related project by a potential client in Atlanta, Georgia. The project was to build a working Hero of Alexandria engine that would be large enough to be seen on stage, able to be transported to more than 60 venues, use electric cooking equipment as a heat source, have a steampunk look, and be reliable over a 13-week tour schedule. As it turns out, the client that needed the Hero engine was Alton Brown, and the show was Alton Brown Live, Last Bite. Alton Brown was preparing a new national tour, and he wanted a large-scale model of a Hero of Alexandria engine to demonstrate what Hero had discovered in 1 AD, that steam had the potential to do work. We took our design inspiration from the original engine and added some steam age details to give it more of a steampunk look. As the design developed, I enlisted the help of a friend of mine, Thomas Fulham, to assist with the aesthetics of the engine. He has a great eye for design, and he refined some of the details to give it a little more steampunk look. The steam supply would be generated by a traditional boiler designed to be in scale with the engine and heated with an electric induction burner. Mike Butler, a mechanical engineer and a good friend of the family, did the engineering on the boiler and specified the welding procedures so we could provide a safe and reliable pressure vessel for the engine. Once Mike was done with the design, the materials were taken to my brother's shop in the Sierra foothills for assembly and testing. Steve TIG welded all of the joints, the bungs, and the stay bolts, and then the boiler was hydrostatically tested to 180 psi. The frame for the engine was laser cut from 3/16 steel, and Steve brazed on a 3/4 inch edge banding to give it a more industrial look. One of the concerns I had from the beginning was condensation. A traditional Hero engine fills the copper sphere with steam and it exits out the two nozzles to spin the ball. Since this had to work immediately on stage and not have a lengthy warm-up time while the copper gets hot enough to stop condensing, we chose to use an armature to distribute the steam to the nozzles. The armature had to spin freely, support the weight of the copper sphere, and leak as little as possible. Traditional mechanical seals really couldn't be used since the drag would be greater than what the engine could overcome. So a sliding fit on 2 oil-impregnated bushings was chosen. An adjustable spider was built to hold the copper ring that the sphere attaches to, so it could be made to run true. Once it was adjusted, it was secured in place with screws. Stainless steel steam supply lines were installed to bring the steam up to the engine from the boiler. The steam makes its way through stainless steel heavy wall tubing where it's distributed to the 2 nozzles through the armature. Once the basic engine was complete and tested, the details could begin to be installed. Boiler insulation and a copper jacket, a brass top plate, riveted trim rings, escutcheons for the steam supply, boiler pressure safety valve, steam pressure gauge, milk frother, and of course, a whistle. We'd love to say this project was a walk in the park, but that wouldn't be accurate. The learning curve on building a Hero engine at this scale that had to work at least 60 times, be portable and reliable, powered by an electric induction burner, and look as if it had been built 100 years ago, was huge. But the payoff was worth all of the stress. Seeing Alton Brown run the engine in front of an audience as part of his show was priceless. We're so proud to have been part of Alton Brown Live Last Bite, and also relieved that the engine did its job for the entire tour and can now take a much-needed rest from show business. We can't thank Alton Brown and his talented production team enough for allowing us to be part of the show.